Now that we've looked at the principles of experimental design, we're going to take a look at a couple of specific types of experiments. All of these experiments fall under the umbrella of a completely randomized experimental design. So this design, all of the subjects are assigned at random to either a treatment group or the control group. The control group receives some sort of placebo and therefore provides a basis for comparison with the other treatment groups. This can compare any number of treatments, and it reduces bias and equalizes variability, and that, along with this random assignment to treatment and control, establishes cause and effect. So the three types of experiments we're going to look at are the randomized comparative, the randomized block, and the matched pairs. We're going to start with the randomized comparative, which is the most basic of these three, and it's pretty much just the basic definition of a completely randomized experiment. We're going to use 2 or more treatments, and we're going to randomly assign our subjects to either the treatment groups or the control group. So this diagram is going to start with our sample, our participants. So if we're using humans, we often refer to those as subjects. If they are non-human, so mice or light bulbs or cars, we would refer to those as experimental units. Whichever you're using, subjects or experimental units, your diagram is going to start with the sample size and then a description of that sample. So in this case, I'm starting with 100 people. And then this is also a really good place to note whether you have a random sample or not. So remember that random sample is what allows you to generalize your results to your population. All right, so once you start with the sample, the middle part of our diagram actually has 2 columns, and this is where our explanatory variable is going to take place. So we're going to start by assigning people into groups, and you want to note if they're randomly assigned. So remember that randomly assigned is what gives us cause and effect. So we'll put the number of people assigned to each group, and then each group is going to be assigned a treatment. So here's how the treatments work. We have a factor, and that factor is the variable whose levels are manipulated by the experimenter. And levels are the specific values the experimenter chooses for a factor. So if I'm testing a cold medication on these 100 people that are sick, and I have 2 levels here, I have either you're getting the medication or you're getting a placebo. So you can have lots of levels. You could have a placebo, a 200 milligram, a 400 milligram, and an 800 milligram tablet. Right? So you could have a variety of different things. In this one, I just have 2 levels or 2 treatments. So the treatment is any specific experimental condition applied to the subjects. If you just have one factor, it's just the levels, and it's really straightforward. And if it has more than one factor, then we're going to talk about what to do. It's not super tricky. It's just a little bit time consuming, and we'll take a look at that. All right, so our diagram starts with our sample. We'll split people into groups, we'll apply a treatment, and then at the end, we're going to talk about our response variable. So this is our dependent variable, and this is the outcome of the experiment that's going to be measured or observed. So this is not something we manipulate. We're actually manipulating in the middle section, that independent variable, in the hopes that it's going to change what happens to our response variable at the end. Okay, and so I also typically write whether that's going to be a categorical or a quantitative variable, because that's going to determine what type of statistical approach I use with it. So in this case, the question is, did people get better, or how better did they feel they got, which is going to be a categorical variable. All right, so let's try this out with our mice example. So remember, we had these 72 mice, and they listened to either hard rock, Mozart, or no music. And we're going to go ahead and diagram this. So we start with our 72 mice. They didn't say it was a simple random sample, but I would say it's probably fair to generalize those results. We'd have to take a look at that and know a little bit more about the biology of mice, but I'd say that's fair at this point. The story did tell us that they randomly assigned the mice to 3 groups. And so if I take 72 and divide it by 3, I'm going to get 3 groups of 24. So I have 24 mice in each group, and they're randomly assigned. And then one group is going to get hard rock, one group is going to get Mozart, and one group is going to have no music. And then our comparison here, our response variable, is how fast did the mice run the maze. Right, so there is our first diagram that we've drawn together for just our basic randomized comparative design.